That's going to be enum and packages fairly quick. Okay, enum. If you miss the keyword class, for instance, in the definition of a class, it's going to say class enum or interface missing. And enum essentially is where you're defining a composite type. It has attributes, but the attributes are all constant. You could define a class where it's just all constants, but it's syntactically, it's easier to define a enum. That's its purpose. Kind of like a tuple. A tuple's, I don't like the Java tuple. It's implementation where it's basically a composite where it's immutable. If we wanted to say store unchanging information, a tuple wouldn't do it. It really can't think of a need for a tuple. The closest one I could think of was pure octable, and we wouldn't change, say, the symbols and the weights, but it's not great. If we wanted to do it, pure octable information doesn't change, then we'd probably use the equivalent of an enum, the information about each element. Other things, these codes, they tend not to change. So we could have these course codes, these 4-character ones, 4-letter ones, stored as enumeration. We don't change the CPU. As long as I've been here, they haven't changed it. It's probably existed since the departments existed many, many years. So syntax, when you define enum, it has to be in a .java file. Attributes are constant. You don't, it's actually easier to set this up than with a class. Example over here, you don't have to trace the code. We have class person. Person has moods. These are just a small set of the moods. So here's how we define enum. It's defining that set. It can't change the happy, for instance. Syntactically, yes, we could define 4 attributes, make happy, sad, final. It's easier. It's public because just like a class, if it's public and it's in its own file, so if you actually look at this, it's going to be in a file called mood.java. We can use the moods, instantiate the moods, have a reference to a mood here, but it's all constant, so it's not mutable. And then we can actually call the constant. It's not instantiate, sorry. And we can use it in another place. Access the constants here. So it's treated like a name constant. Why do I actually make it public, put it in its own file? Well, just like say with the math constants in class math, you have pi. They've defined it to a numeric value up to a certain amount of precision, 3.14 up to whatever digits. You might want to access that in your own program. A mood, besides people having moods, animals can have moods. They can be happy too. So we make it available. Any questions about the enum? The enum I saw at the very least, I skimmed it. Well, actually, someone asked me a question about it. I didn't look in detail for this new version of A2, but the new version of A2 in its starting code uses an enum. So he's defining some constants. And if I recall, looking at the code someone sent me, it's defined this way. It's its own file, its own definition. Now, I decided to specifically have 2 versions of enum because in the Hudson's course notes, he does it this way. So the definition of the enum is inside here. It hides it. I didn't want to do it this way only, although it takes more time, because it implies syntactically they have to do it this way. That's obviously not the case. Most of the time, you probably want to do it this way so that these constants are available. We can't physically change them because they're constants. You can't set them to the wrong value. So it's okay that they're universally available. They're essentially global, acting like global constants, not global variables, which is okay. Constants are okay. Unless it's private information, like I don't know, social insurance number. That's where having it public's not a good thing, or password or whatnot. Okay, in this case, private moods. I could have had a full program where I was trying to simulate human behavior, but that's not the learning lesson. I'm just trying to show if you actually nested a definition of something, a class or a enum inside another, it basically limits the scope so that I can only access private methods within class person. Why would I do this? I could have moods, my external mood, I look happy. I try and stay happy all the time, as an example. But really inside, I really feel really cruddy. And I could have had a simulation program where the internal private moods affects the external ones, but that wasn't the learning objective. In case you wonder why I have private moods. Okay. So if we tried to access the information about private moods outside the definition here, syntax error. It's not visible. We can't access it here. And I made it over here. It's sufficient that it's actually inside this definition that we can't access outside. If we made it private, that would be something else. There's no need to make it private. Right now, if we have a child class that inherits from this, it can still access it. Private, it wouldn't, as we'll see. Resources on enums if you need them. Packages. You have used Java packages already, but this section is about defining your own packages. What's the advantage? So a package is like a library. You name it, and we have certain classes associated with it. What's the advantage? Well, small programs, you don't need explicit packages, but in real life, you do it. One advantage, finding a class. Example, if you were looking for a graph, let me think for a sec. Well, file IO, there's a simple one. To read from file, text-based. You wouldn't have to look through all the Java classes. If they design this properly, you look for something for input-output package, which is where it's located. So this is where you narrow down your search to the package if they designed it properly. That's precisely what I'm talking about right here. Another advantage is naming conflicts. If we have two classes by the same name and they're in the same package, it's like having two variables with the same name. Problem. There are two class objects, but because it's a fully qualified name, this is almost like, say, an area code. We can have two phone numbers and two different area codes, and there's no conflict. If we want to refer to one, we could actually include this org, omg, corba dot object, and it would disambiguate which one we're referring to. The third thing I'll make you aware of, I took out the code example where I actually had showing this, because he doesn't have it. I'm trying to save time. But when we talk about inheritance, he actually does talk about this fourth level, in theory. What we can do is, if we have a helper class that basically only performs functions to help out these other ones, it's basically a helper for the other ones in the library. It's not meant to be used elsewhere. We can set the permissions such that the helper class is only visible here. Essentially, it's a package level visibility. That's the advantage of packages as well. This third, where you can hide certain classes where it's not appropriate to access them outside of the package. Importing packages. I've imported them unless I initially did it the lazy way years ago. I did this. I only import a single class. Why? Because if I import this Java util star, that means the import, well, first, this import allows me to create a vector. It knows the vector class. If I left this out and I tried to create a vector, it would say, I don't know what vector is. It's not in the standard java.lang. So I import it. Now that name's available. The thing is, if I import star, every class name that's in here is going to be imported in. The more that you import, the more likely that one of those names will conflict with yours. Now, with your starting programs, they're really small and it's a low probability, but real life projects have lots of classes, hundreds or more. The more that you import, the more likely you have a naming conflict. So you only import what you need. So a wild card you really shouldn't do, unless literally you need many perhaps. But if you just need one or two, don't be lazy. Okay. Java.lang, it's so common. The system outs, text-based output, don't need to import it. Utility provides functionality. They're useful, as the name utility, but they weren't deemed as being common enough to include in the standard one. The more they include the standard, the more likely it is for a naming conflict. You could write your own random number one and not use this one. So that's why they include it in the standard group. So you either need to have an import like this, and then you can just have that class name, or you have to have the full package name. This, by the way, is the package name. That's the class name. But every time that you refer to random, you have to preface it with the Java util, so that's awkward. So that's why we actually import it, so that name is available. We tell it that it's in this library, and we don't have to do all this stuff. The default package. You have been actually defining code within a package without knowing it. When you actually create a class, you have that public I think IntelliJ actually adds a package for you. But if you do it with just an editor, this actually belongs to a class. It's a default, a package, default package. What's included in that package? Every other class definition that resides in the same directory. Because if you set a permission such that it's only visible, something's visible within the package, you'll still be able to access it. If I told you of attributes that are variable, they should be set to private, all that. And you all have been good where you haven't done something like you haven't save it, it's slow. I accidentally hit Control S, sorry. If you leave out that modifier, it's actually not a syntax error. That is package level access. This is where I used to have full code examples. It's still accessible in the rest of your program. We can still access that num because they're all in the same package, unless you create another package. And that other package classes, the class in that other package won't be able to access it. So when we talk about private, this is where we can actually restrict things to only classes in that package. And same here. If we do this, that means class person is only visible to classes in the same package. In other words, in the same directory if you don't name anything. And I'll stop here. Yeah, okay. Okay, so this part, when you're actually, this section is not about using packages, but defining your own packages. When you define a package, you might be, you'll be defining for your own use, your own team's use, but there's the possibility you're defining useful code, multiple classes that other people could use. Consequently, what you should be doing is thinking ahead and designing, naming it so that it's guaranteed to be unique. Because if it conflicts with another one, then if it happens to conflict with another package name, class name, then people won't be able to use both. It might be very rare, but you don't want that possibility of having unique addresses and phone numbers. Consequently, Simon came up with something that's guaranteed to be unique. One is web addresses. So this is a non-existent one, but say we have a web address. It has to be unique because if there's conflicts, then which domain do you go to? And their convention was they flipped the web address. So if it's .com, the order. And we can have, this is the main package, but then we can have sub packages as well too. And they actually did this for some of their packages with the GUI libraries. This is the alternative to JavaFX, Swing. The URL, one of the many URLs Sun had was this. Then the package name for Swing, they just reversed the URL. And later on, they reversed this and decided to actually change it to JavaX Swing. But they did follow this convention. Now, if you're a developer and you don't have your own web domain, the other thing that is guaranteed to be unique is your email address. So we could flip that and use an email address as and now what we have here and what we have here, these are package names. Well, this is labeled as package names. This is a package name. This is a package name as well too. Okay. Now with this example, directory structure is important. Right now, package example, this is a folder. If I go to a simulation, a recreation of my web folder, so I copied it to a local drive. Did I copy this? No, not yet. So I just gotta grab it from another drive over here. Been adding so many new things, sometimes I haven't done it, copied it to a local for a class. So we got, I might as well copy that. Oh, do I have an oh, I do have an unpacking, but I don't have a hierarchy, so I might as well do that. Okay, under enumeration and packages. No, actually, it's kind of not a bad thing to have both of these open as well, too. So come on, open up, open up. Oh, sorry, clicked the wrong one. That's distracted for a second, like someone in from the waiting room here. Okay, so we have this under fairly long, oh, crud. Under fairly long path name. It's an external drive. Fine, it's not too big a deal, but it's contained all these enum examples are contained in this folder. Over here, we have it under the internal drive here. However, under week seven, we have the package example. Package example is a folder and it contains everything related to the package example. Now, these two paths are going to be different. This is for the one USB drive. This is the internal drive. And that's what I'm referring to. Anything above package example in terms of directories, it can vary anything. It can be in the C drive, for instance, by having a subdirectory of C drive. But we have package example. That directory contains your directory structure has to match up your package organization. Pack1, aptly named, is a package called Pack1. Pack2 is another package. Each of these packages, the code classes for them is in their separate folder. So we have two packages here. However, recall what I said, if you don't actually have an explicit package name, these ones have an explicit package name. You put this at the very beginning of the program of the class, and that says that this person.java is part of package pack1. This version of person.java is in should be pack2. Typographical mistake, shoot, pack2. However, driver is not in an explicit package. It's importing something from another package. It doesn't have the keyword package. So that means it's in a default package. So we actually have three packages, 1, 2, and 3. And if we had other code in here, in this directory, they would be part of that unnamed default package, which is why I said that if you leave out the keywords, if we have an attribute, and this would have to be static since we shouldn't instantiate the driver. Num is now package level access. That means only classes, classes in the same package, we'll get to actually which ones can access package level. The classes that are in the same package, in the same directory, can actually access num. However, these classes cannot access them because they're in a different package. There's another exception to it. There's inheritance, but so I carefully word that. If it's package, if we don't specify an access level, it's package level access. And they don't have the package keyword, likely because it's used here. If it's package level access, then the classes in the same package can access it. And all things being equal, classes in other packages cannot access it. But then we have inheritance, which could allow it to access. That's something we haven't talked about in great detail. So here's the code for each of the person. Now I picked this partly because person is familiar, but partly what if we have naming conflicts? Well, we don't have that naming conflict. There's like a phone number. There's the same phone number, but we have an extra little part in the name, like an area code and a country code. We can qualify this through the package name before person. And just so you can see something different, they're not identical. The difference between the two person classes, one has an age attribute, the other has a name attribute, but it doesn't really have, the actual attributes aren't really hugely important. It's learning objective is defining your own package. No imports here because we're not referring to any other classes externally. But the driver class, it will refer to, whoops, very careful this. Take back's not very good. Actually, just don't save it. The driver class will refer to person in package 1 and person in package 2. I show how we can work with classes in other packages, both with an import and without an import. There's no naming conflict because we have a package here, and we only import person, class person, from pack 1. That means this ties into this. We don't need, when we refer to the name person, we don't need to say package person, pack 1 person, because we imported this name here so that we're aware of person. However, I didn't import pack 2 because pack 2 contains a person. If I imported it, then there'd be ambiguity between person in package pack 2 and package pack 1. So in this case, I didn't import it, so I need to have the full name. So it shows two things. What if there's naming conflicts? Well, then we can include the package name. So we can distinguish one person from another. This is the one that has an integer attribute. This is the one that has a string attribute. Furthermore, what I'm doing is just to show the learning objective. For packages that we define ourselves, what happens if we import it? It's just like another package that's pre-created. And I have the name of the reference to tell you which package it's coming from. Or if we don't use an import, then we have to have the fully qualified name. Now you see why Sun's naming convention for naming packages is important. You want to guarantee that these are unique, even if it's an odd chance that your class name and your package name, your class name is going to conflict with someone else's. Adding in that package name, if you make sure it's unique, then there should be no naming conflicts. And then this part's just getters, so that's not a big deal here.